Alright, welcome back. It's been some time. Probably this is going to be the most important video of this channel ever. It's Lisp, but why? I've done a bunch of but why series, so yeah, it's been quite some time since I've done one of these. I've done one for Emacs, Tmax, Vim. I try to whenever I do a but why series, it's mostly for tooling that I want to philosophically reason about. Lisp has sort of been a very influential abstraction over the past 5 years of my life. That is an understatement, probably. That's still probably an understatement. It's not capturing the essence of the extent of the extent of influence that Lisp has had on my life over the past 5 years. Uh, when I sort of do these but why series, this is the fourth in all of my videos. I try not to reason in a technical manner. I mean, I try to give a more anecdotal take on it. So before I actually get into the anecdotes and the history and how my understanding evolved over time, let's cover the technicalities, the basics. So a lot of people assume that Lisp is the parentheses. The parentheses make the Lisp. The parentheses in themselves are not what Lisp is about. They facilitate an idea. They do not actually make Lisp. So, what makes Lisp a Lisp is basically, I've cruxed them into two major ideas. The interesting ones that lead a Lisp to a Lisp is homoiconicity, is the notion that code is data and data is code. So having a representation, an abstract representation for data and code, that is interchangeable. In the context of Lisp, when you use Lisp, by the way, stands for list processing. So it's representing syntax code as a list, as a data structure, and list in itself is the data that it manipulates whenever it works upon anything. So the data is represented in a format that the code is also represented in, and yeah, so you could also represent all of your source code is a list, and if that's the case, you could write data that could be evaluated later on to evaluate lists or source code. So if source code and data is interchangeable in a lot of scenarios, you have the concept of homoiconicity. And recursion, structure and behavior, in the sense that a list can be composed of other lists, so that gives rise to trees. So that is where your abstract syntax tree, the notion of an AST, arises in the context of Lisp. Gives a very powerful, of course, behavioral recursion is something that a lot of us will be aware of. Calling functions at the end of a function, that's the behavioral recursion that I'm referring to. And structural recursion in the context of Lisp is lists also being able to contain lists for the lists. So that's structural recursion. So like how a tree contains a subtree, a tree contains references to a subtree, that's sort of structural recursion. Those are two powerful intrinsic ideas that make a Lisp a sort of a Lisp. And the extrinsic idea that evolves as you continuously use Lisp over a long period of time is something that I'll not name drop right now. I'll try to arrive it by the end of this video in a very natural manner. I'll try to arrive it in the sense of how I realized it, how I understood it. Of course, this will explicitly be there for you in a lot of textbooks, a lot of essays that you read. But yeah, the point of this video is to sort of express this extrinsic, the way Lisp changes you as a programmer, as a human. That's the point of this video. To express that in probably 30 minutes. It's going to be a challenge. It's a pretty ambitious take on it, but let's see. I mean, to help you grasp Lisp in 30 minutes, because this is the sort of thing that a lot of people just reject because of the parentheses. but then let's try and go beyond that in this context. And I'll over the series of over my past 5 years, I've used a whole bunch of dialects, and what I've learned along the way, I'll try to condense that today. So hope we have a successful but why. Again, I these are probably my favorite type of videos, the but why series, to actually philosophically reason about a tooling that sort of has this mystic aura about it, that is not explicitly explainable to the usual human, the usual programmer. I mean, yeah, let's get into it. So the objective for today is convey the power of these ideas anecdotally, and of course a lot of ideas in today's programming language theory do root from Lisp, but my objective is not to cover all of them today. We'll of course build a series over a period of time to give them the due attention that they deserve. I don't want to condense everything in just one go. Why I am emphasizing on this being sort of a very, I don't know, this video is sort of very personal to me, because there was a point in time when I was dreaming in as expressions, and that was probably the most fun I've ever had in computer science, in programming. I mean, to this day, whenever I get into a Lisp, I get to programming a Lisp, I have to hold myself back, because I mean, I got a job and I so I have to do some chores and that sort of stuff. So whenever I get into a Lisp, I have to hold myself back. I have to allot a quota as to how, when do I stop. So that's it's sort of a, yeah, it's a way of getting addicted to a certain way of thinking, which is fun. It's beneficial. I wouldn't say it's an addiction. I mean, it's a symbiotic way of thinking. So it's as if finding your own venom. So yeah, let's get into it. So those are the objectives of this video. We've laid out the context, and now we can begin. So my path so far. Usually people get into Lisp from this particular path. I mean, this is also the path that I followed from Vim to Emacs. They get into Vim because something like a modern editor like a Sublime or VS Code doesn't look cool. It doesn't feel cool. It does the job, but then it's not it. You don't feel like you're programming. Yeah, you have to pick up the mouse. You need to develop a certain hatred for the mouse to sort of you need to love efficiency for getting down this path. So I used Vim for around 18 months when I was 18, and then I switched to Emacs because I did not want to I wanted to get into extending my tooling, but then Vim script was not it. And if you're using Vim, you're aware of the whole EVOS, and Vim versus Emacs is one of them, probably one of the most popular one of them, Vim versus Emacs. So I hopped onto Emacs. I jumped ship after reading up a little. Mostly that can be attributed to two essays. One by the founder of Y Combinator, Paul Graham, one of the founders of Y Combinator. I think there were 4 in total. Yeah, one of the founders of Y Combinator, Paul Graham. Beating the averages. That's where he talks about. Yeah, beating the averages. I'll not spoil it for you. Yeah, I mean, he's a pretty good writer. Reading an essay of Paul Graham should not be spoiled by someone just having commentary on it before you actually read it. So link in the description, of course. And that essay also leads to another essay by Eric Raymond, How to Be a Hacker. That is also a very good and influential essay from my early days of programming. I still read it from time to time whenever I whenever I sort of lose my sense of direction as to why I am programming. There's a whole bunch of other essays as well. I mean, I could have a series, a good collection of essays which I like to read from time to time. So How to Be a Hacker is something that I read from time to time whenever I'm sort of feeling when I want to revive why I program, actually, like the mindset that sort of goes into it. So it's pretty good. Now now sort of I've got Emacs, I've got vanilla GCC, vanilla Emacs. I used to use WSL too. By the way, there's a whole journey of my editor. Was there's a video out there. I'll put that in the somewhere in the top right or left. That you should get a iCard pop up. So yeah, the next step into achieving more depth with Lisp is SICP. SICP is, yeah, I mean, it's the book that changed my view about computer science. To give you some again, this is not worth spoiling for you. SICP is not worth spoiling for you. All of the essays and books and tooling that I mention out here, you probably should experience them firsthand. Imagine what would happen if you never watched the movie like The Matrix, and I just gave you descriptions about it. It would completely ruin your first experience of the movie. I don't want to do that with you. Yeah, I don't want to do that sort of a thing with you. So SICP is something you should definitely get into. It starts with the prerequisites are basic high school math, and it takes you on a tour of computer science. Very powerful concepts in computer science with a very basal Lisp, a minimal Lisp, a minimal variant of Lisp scheme, and I personally did it in Racket. It's a modern scheme. I started out with High first. High is a Lisp dialect in Python because I was mostly doing some AI research then, some computer vision stuff then. So High was like pretty easily accessible right away. But now, I mean, then I moved on to Racket because High did not have tail call optimization. So I explicitly remember seeing that then and being like, yeah, no, that sucks. So tail call optimization was something important because of the way you program in Lisp. So that is something necessary that made me jump ship to Racket. Recently did I think 2 years ago I did an advent of code in Racket. The one after that I did in Common Lisp. Probably the next one I'm thinking of doing it in Clojure. This following one. Clojure is what I'm exploring right now, but then we'll get to that at the end of this. And yeah, SICP. I took 2 years to actually complete that book. I did it during my most busy years, my sophomore and my junior year. My computer science curriculum was pretty intense back then. Intense in the sense pretty involved back then. I was also doing a minor in AI, so already pretty busy with lectures and stuff. And yeah, I completed SICP during that time. So I did the exercises and everything in Racket. It's probably there in a GitHub repository somewhere. But then it's probably the most influential. It is the most influential book in terms of the way I think, the way I like to think about the problems that I solve in general. Yeah. Then I moved on to sort of the more esoteric aspects of Lisp. The most esoteric okay, so because of SICP, I was hungry for more books. So I never got to actually getting to that book. The book called Plateau Lambda, LOL, Plateau Lambda. That was the book that I wanted to get into. But then there's a whole bunch of prerequisites for that. On Lisp is sort of said to be the first step towards Plateau Lambda. On Lisp is again by Paul Graham, and Practical Common Lisp is by Peter Sebel. So Practical Common Lisp is more of an industrial take, more of a practical programmatic take, whereas On Lisp is sort of a more. You should also read Hackers and Painters by Paul Graham. Probably a lot of stuff by Paul Graham is worth reading. Yeah, so Practical Common Lisp and On Lisp is what I read next. So I also did an AOC, the last AOC in Common Lisp, and I also started a series on YouTube called Common Lisp series where I this is not my first try towards explaining and popularizing Lisp, by the way. I mean, yeah, there was an attempt before. Hashtag there was an attempt. So that's the link. I'll drop that in the description. That was like probably more than a year and a half ago, where I was exploring. I was trying to yeah, I was trying to get good with Lisp by teaching. So I have a couple of videos in, and I am dropping those for the sheer awkwardness, sheer awkwardness, and the way I was back then. It's probably a nice time capsule out there. I was not a Doom guy then. I was a vanilla GCC Emacs guy. So you'll probably not see the same setup then. But yeah, it's nice. It's nice to see. It's nice to get back in time. There's some nostalgia out there, and I hadn't also founded the Bit-Mage then. My domain was rajpatil.dev. So yeah, I was just getting into Lisp. I mean, getting into Lisp in the sense that I was just truly understanding the deeper nature of things that Lisp sort of enables you to do. I mean, I was seeking enlightenment, of course. Everyone has seen XKCD memes. If you googled a little regarding, or people just claiming Lisp will sort of enlighten you. I mean, I was actively chasing that. So yeah, I was reading whatever I was following a lot of paths, following a lot of roadmaps. But yeah, then I was sort of there was this plateau for a long while where I was just not getting it exactly, like what is the what exactly is it. So yeah, we'll get to that. This is where I had to stick through it. I mean, I tried getting in and out again and again, but yeah, to truly get it, I had to be sort of patient. I had to sort of get back to the real world, get into some engineering problems, and sort of get back to Lisp from time to time. So it's been probably more than a couple of phases, where more than I don't know, at least 3 or 4 phases, where I've sort of taken a minor breaks from Lisp to let all of this simmer, to let all the new stuff that I consume simmer, slowly integrate what I've learned along the way into what I've been doing. And the way to do that most efficiently is get into Emacs. Emacs is what made me sort of witness a practical instant of power that Lisp provides, to sort of move on from basic configurations to extensions. That has been a journey, and of course you do that in eLisp. So you use eLisp is what you do in Emacs. So to move from just basically configuring your editor, which is already doing in Vim, to writing some of my own packages for specific stuff that I want to do that integrates with other packages. I've wrote 2 so far now. I wanted fabric prompts in GPTL. GPTL is an LLM client for Emacs, so that's one. And the other is I wanted multiple org-room vaults and convenient switches from them and context management. And I didn't want to reload the caches again and again. So some context management, basic context management around org-room. That's another package that I've wrote. So both the links will be in description. So to move from just basically altering your themes, setting variables here and there, to actually writing a package that you actually use day to day. So these 2 packages I use day to day, and it feels nice to say write something that is of actual practical use, that has been helping me for a while and has been easing off my daily loads. That is what Lisp sort of enabled me to do at this stage. So moving on from the idea of editing text to treating text in a more abstract manner, seeing it as buffers, seeing it as stuff that you can cut down in the kill ring, yank from it, seeing the data structures around text, orchestrating text as a whole. Emacs has been a practical realization of that power of Lisp. So here we're getting to sort of an important point. We are now dealing with the explicit problem of editing text. Any usual other editor might build some abstractions, as to say the idea of a buffer or a tab. So that's your usual object orientation way of seeing things, behaviors, attributes, that sort of stuff, objects, instances, classes instances. So you could either model it that way, but then the way Emacs does it is, again, I'm not name dropping this stuff, but then it is the extrinsic aspect that I was talking about. How Lisp actually encourages you to solve problems. So the problem being solved right now in the context of Emacs is editing text. It is a very elaborate problem, and text is sort of one of my favorite modes of communication, favorite modes of persistence, of conveying and storing information. Text is awesome. So text orchestration, yeah, and text, by the way, can represent a whole bunch of things. So just text orchestration. What Emacs does is builds a language around it. It builds a domain specific language around text. eLisp is of course, it's a it's a general purpose programming language as well. It can do that, but then it's a DSL to edit text. So this idea of DSLs is what was very powerful in this particular moment for me. And okay, eLisp is a practical realization of DSL, of a very powerful DSL in practical use. Emacs is what, like 35 years, I don't know how old it is right now. I probably should know, but yeah, it's very old. Emacs is old. It's still going, and it's more than just keeping up. It's beyond being it's beyond comparison compared to what any of the other tooling is doing out there. It's going to stay there for more than a while. Cause of the way it is engineered, cause of the way it is expressed in Lisp, because of the abstractions it is built upon, and the transparency and the fluidity of those abstractions. So right now I might just be sounding very vague, but then this expressiveness, eLisp is, again, by the way, just as Turing complete as C or any other higher level language is. But then what Lisp does is those two things, is those two intrinsic things of homoiconicity and recursion. It makes it very obvious to use them. It makes it it facilitates their usage. So in C, you probably, C macros are not the same as Lisp macros, or in the context of C, your data is you're working with actual bits and bytes. Your data is actual bits and bytes. Your 64 or 32-bit registers, that's your data, that's your core data. Lisp gives you an abstraction of symbols, of lists. That's what you work on, and lists are also how you express code. So that idea of homoiconicity, that idea of code being data being code, interchangeable representations of the two. So you could say have code act on code. You could store code as data. You could later force evaluation of data into code that evolves another data or code. That whole idea gives rise to metaprogramming. So homoiconicity is the basis of metaprogramming, and recursion. So I did mention leaving high, because in those days I did not have tail call optimization. I'm not sure about what it is right now, what's the current state. I'm not sure about that, but then it did not have tail call optimization. And the way you write functions in Lisp is usually not iteration. So if you're looping around in Lisp, if you're using a whole bunch of loops, it's probably not in alignment with idiomatic Lisp. So iterative recursion, that sort of stuff. Tail call optimization is extremely necessary to sort of optimize that and completely enjoy programming. So that's why I do like a scheme for myself, but then I do also like the robustness and industrial aspect of a common Lisp. We'll not discuss the internal tribes of a Lisp. The idea right now is just to express the idea of a Lisp as a whole, not as an ecosystem right now, but then the idea of a Lisp. That's the why that I'm getting into today. We'll get into these later on, of course, the individual dialects and schemes and not Lisps. We'll get into those, but yeah, Emacs is the first explicit interaction of any Lisper with a very powerful realization of the idea of solving domain specific problems. In this case, editing text. So now, how do you extend that? How do you extend that to the generic idea of solving problems in life? That's where, of course, you get into your higher level software engineering and stuff. So I've been reading Software Design for Flexibility right now. It's sort of told to be successor of SICP, SDF. So it's fun. It's actually very interesting. And also I work in the cloud domain, so a lot of data center orchestration and stuff. So Go is sort of out there for concurrency, and for that I've also been chasing Clojure with a J. Explicitly, and I'm also exploring Clojure. So Clojure is something that yeah, has been fun programming in, and yeah, let's also, yeah, I'll refrain from saying why these tribes exist and stuff, but then Clojure and not common-lisp, because it has native vectors, maps and sets, and concurrency is right there baked into the spec. Every Lisp out there exists for a reason, and that reason is the problem that it solves, the domain specific problem that it solves. So the pattern that I want to convey here right now is, it helps you think generically towards solving any problem, and the way it does that, are we into it right now? Is it the right moment? Let's yeah, yeah, okay, hold on, we're still not into it. So I'll drop the name right now. It's just below this expansion, the extrinsic. So let's zoom in again. Yeah, before I drop the name right now of what Lisp enables you to do, thinking in Lisp has never gotten old for me. Anytime I sort of approach a problem, it's infectious in a good way. I mean, yeah, it's accelerated the way I solve problems in a very elegant manner. How I do that, I'm going to name drop that. Give me a minute. Before that, a lot of what you see is influenced by Lisp. The tagline of my blog, the logo, it's parentheses around the symbol Bit-Mage. So call upon the Bit-Mage, invoking the Bit-Mage. And the tagline of that, apply eval, sudo, explore, exploit, is also an amalgamation of Maxwell's equation of software, apply and eval, just those two things. Alan Kay said this. I'll link that in the description. Those are sort of the Maxwell's equation of software. all of software sort of could be expressed in those two abstractions, apply and eval. So as you can see, there's a pattern that Lisp has sort of been a very, very influential abstraction in a whole bunch of content that I create, in the way I carry myself, the way I think. And this generic power that Lisp yields you, the enlightenment that it yields in the way you think about stuff, the way you approach anything, is metalinguistic-abstraction. Now, that's a Wikipedia page out there. It's more about thinking in domain-specific languages itself. When you see a problem, rather than modeling the problem in terms of the language, you make the language meet the problem in the middle. You sort of evolve your language and formulate your problem at the same time, even before you sort of begin thinking about the how. This powerful idea of this powerful idea of explicitly breaking down the problem and building up the language has been expressed in a lot of books. There's probably an explicit chapter in SICP. Paul Graham also talks about it a lot. There's a whole bunch of books on DSLs. Racket is a programming language oriented language. So think of that, the meta-ness, the meta hyphen ness of that. It's a very powerful idea. Metalinguistic abstraction. It changes the way you think in general about problems. So that is the why of a Lisp, any Lisp for me. Any problem that you get into, building up DSLs, getting good with them, and having all of the power of that expressiveness that Lisp provides with homoiconicity and recursion applied to the way you approach a problem via metalinguistic abstraction. Yeah, that is the why of a Lisp for me. To actually frame that this way took me 5 years. Took me 5 years to frame this way. So I hope, I don't know if it was useful. I definitely did try, and yeah, I think that's it. That's 30 minutes. 30 minutes I've rambled on about Lisp. So before we sort of leave, this idea of solving problems, formulating them, understanding them well. We have a sponsor today that sort of specializes in that. We got a sponsor, CognWare Industries. Let's plug that in for a while. So what do they do? I mean, the founder out there, he believes that technological and cognitive evolution go hand in hand. The technological evolution around us is taking care of itself. There's this research that we cannot keep pace with. But then the way programmers and humans think in general also needs to level up, and this needs to happen at a more basal level for humans to truly exploit the technology around us, to truly exploit the way they use tech, rather than just using them as a hammer everywhere, trying to truly understand the force around you, as in force in the sense of may the force be with you, that sort of force. Understanding matter, the fundamentals of it. So that sort of cognitive stuff, to truly understand your tooling, that's what that guy works on. I out here work on the technological aspect, the what, the how of stuff. He works on the why. He works on the why and some mixtures of this from a more cognitive aspect as to how you should actually be using tooling, how you should actually be using technology. And he has an offering called a SaaS. It's serendipity. It's serendipity as a service. It's a daily video essay. So he has coffee and rambles until the coffee runs cold. Daily video essays accompanied with vlogs, with blogs that sort of summarize the whole thing with tagging and stuff. He's building his own cognitive infrastructure in the sense that he's building a whole bunch of stuff. There's the links. He's got a YouTube channel, and they've also got a blog. So check that out. He's a partner henceforth, sort of a permanent partner. So check that out. The domain at your right. Yeah, it's your right on the screen. And that's CognWare. That's where they're hosted. That's it. They are explicitly working on the more extrinsic aspect of solving problems. I out here will be handling the more intrinsic aspect of learning how to solve a problem. So concepts like homoiconicity, recursion. There's a whole bunch of stuff that goes on. That's what I handle. That's what the Bit-Mage is going to handle, and CognWare is going to complement that with the extrinsic aspect, metalinguistic abstraction of framing problems and solving them and trying to solve them across. Of course, formulating problems from the first go. He offers the SaaS. Check out that. Serendipity as a service, a very interesting take on having a SaaS offering. So do check that out. Yeah, that's the sponsor plug. Thanks for sticking through that. we are going to go back to where we were. Is that it? Is that it for what we were going to discuss for a Lisp? Definitely not. There's a whole lot more. We're just getting started. This channel is sort of this channel is sort of moving into the weeds now. We sort of laid the foundations. My audience, I feel like it's sort of getting what I want to convey. So it's getting there. We're getting into the sort of a newer phase of what this channel will get into. What's next for us? So I'll be exploring the whole bunch of computer science as promised in the description of this channel. It says full stack CS, ellipses, comma, ellipses, and some more. So of course we'll do that, and we'll do that with Lisps. We'll do that with a whole bunch of different Lisps and schemes. Yeah, I'm not a very tribal person to any Lisp or scheme out there. I like enjoying them all. I move around from time to time. So yeah, all the Lisps that arise in the future, the ones that already exist, the ones that probably we might accidentally invent sometime. So I mean, this is a long-term thing. I enjoy computer science, so I'll probably stick to this for a long term. And the domains that we can explore are there's no limits to it. CS, of course. I mean, the whole bunch of things in CS. There's programming language theory. Neurosymbolic AI is also something that I'm heavily into. I also quite am a proponent of that. Quantum computing is something that I dabbled in previously, but I'm putting that in there to sort of highlight the vastness of domains that a Lisp can handle. Any general purpose programming language can handle it, but of course the way the founders of the domain choose to think in is what gives Lisp its status of being sort of an elite language, something for mystic stuff. And yeah, mechanics and stuff, and from the practical, the pragmatic, to the completely abstract, we're going to use Lisp everywhere. And yeah, I mean, I'll move around from point to point. I'll move around from different domains, but presently we will start off with software engineering. And we go with practical software engineering. For that, I'm going to use Clojure. Why? Because concurrency is sort of a native thing baked into the spec. So Clojure is something that I'm actively enjoying recently. We'll start out with Clojure. Yeah, a lot of practical CS, a lot of industrial stuff. I'd like to explore that in that. So this season, the season of Clojure is what we're starting out with. And yeah, we'll explore a whole bunch of things, right from the basics, setting stuff up, to actually analyzing abstractions, how Clojure handles it, how it interrupts with the practical world. So it's built upon the JVM. It runs on the JVM, the Java Virtual Machine, and you can do sort of full stack computer science with Clojure, with from the at the client side being Clojure script and on the back end being Clojure. And yeah, it's a very interesting playground in itself, software engineering. So to sort of level up my competence as well, I'm going to explore this via Clojure, and we're going to have a whole bunch of series of videos on that. What I want to say here is I could go on and on as to any domain that I pick up, because of symbolic algebra, semiotics, that sort of stuff has changed the way I think, and what got me into it is Lisp. So to say what sort of level I hold this idea in regards to, the movie The Matrix. Yeah, I feel like there should be an equivalent movie, The Symbol. Yeah, I mean, it's sort of it's only something that's waiting to happen. It's the lambda calculus to the Turing machine that The Matrix is. A movie something like Symbol. Yeah, so that's something that's waiting to happen. I feel like I don't know if there's a movie that's already The Symbol, but an equivalent movie where a neo, okay, rather than a neo is just a play on the word one, right? So we'll need a play on the word, I don't know, lambda or something. Rather than seeing streams of ones and zeros, you probably see symbols manipulating other symbols, transformations flying around. So that sort of stuff, that movie's probably waiting to happen. I don't know. Yeah. So yeah, that's the extent of regard that I have for this idea of symbolic algebra. And yeah, I think we're getting to it. Yes. Yeah. So these were my 5 years into Lisps, and how they've changed me. I mean, I'm not claiming to be completely enlightened, but then I'm definitely a better programmer. I am not a Lisp god yet. I mean, there's no shame in claiming that I want to be one. It's a very interesting and ambitious pursuit, of course. But yeah, I mean, I would enjoy being one. I'm gonna work towards it. Getting there should be fun. It's never been and programming in Lisp has never been a chore for me. It's been, yeah, just to think in Lisp to, yeah. I mean, I already mentioned I have to have quotas for my day, as to that's enough Emacs or Lisp for the day, as in no more tinkering. You just get stuff done. You need to have your maintenance stuff done so that you could prolong your usage of Emacs over the period of your life. That's the kind of way I have to think about this right now. So I hope this helped you understand why Lisp, a Lisp, but why. These are sort of the videos that I enjoy the most, the But Why series. Yeah, it took what? It took 42 minutes, and I did not even realize. I did not realize. These are of my contacts, my vlogs. I do talk about a whole bunch of meta stuff in the vlogs. I got my blogs on the Bit-Mage. CognWare is something that I've recently partnered with. They do check out their SaaS offering, Serendipity as a Service. They got a YouTube channel, they got a GitHub where they maintain a whole bunch of things, the blog and some more things. So do check out the blog for that. And of course, there's a parent URL. That's my mail. I am a part of CognWare now. So yeah, that's my mail, raj@cognware.com. Do hit me up if you want to discuss anything. I mean, I'm always open to fun engineering discussions. Yeah, any philosophical ramble. Yeah, then I'm always open to that. My Instagram is ln2.thebitmage. ln2.thebitmage is a play on entropy. Bits are the unit of information with base 2. Bits are the unit of information with base 2. If you multiply the amount of bits you have with the natural logarithm of 2, you get nats. Nats are the natural unit of information. So that's my Instagram. Yeah, I know, I'm like super nerdy. I know, I get it. But yeah, of course, my GitHub is out there. I do like open source. I am for open source. Open source has changed my life. I will also have a whole bunch of videos regarding open source technologies. Unix, Linux, the Linuxes. Yeah, I mean, Emacs, of course, from the full stack of computer science, from open source hardware to open source applications and cloud native stuff. I enjoy it all. Open source has sort of been a very interesting part of my life. It makes my life interesting, from open source hardware to cloud native stuff, the large scale orchestrators and everything. So I am sort of out there on GitHub. So let's if you're interested, that's there. Twitter is where I index everything. Twitter is where I sort of post everything. And Goodreads, I do like reading a lot as well. So I mean, if you do like reading a lot, let's be friends on Goodreads as well. And I think that's it. I hope I did justice to the powerful abstraction that a Lisp is. I mean, I tried my best. I tried my best to also contain my excitement. Yeah, this is, again, I'm saying it again, probably for the second or third time, probably the most important video on this channel, probably ever. I mean, hashtag there was an attempt to express the essence of Lisp in 45 minutes.